For our STEM project, we wanted to find out what amount of water makes a water rocket fly the highest.
For this, we needed a tape measure, cones, inclinometers, a water rocket, a pump, a measuring jug, clipboards, paper and pencils to document our results, and most importantly, water.
Our first attempt of the experiment was a fail. The pump fell apart. Water leaked from the rocket. We weren't pumping very well and there wasn't enough time to carry out all we had to do. Since that didn't work out, we tried again.
Our second attempt was much better compared to the first. We tried using a larger pump, but this didn't work no matter what we tried, so we went back to using the original pump. This time, we also put the rocket on a clipboard so that when it launched, the water wouldn't dig into the soil and grass, which would make the rocket not fly as high.
To figure out how high the rocket went, we used trigonometry. To find out a height, we needed an angle. We measured this angle using an inclinometer, which was used at eye level. I will now show you, using an example, how we found out the height of the rocket. This is our rocket going zoom up high. This is where the rocket started off, and this is a person using an inclinometer at their eye level. This is our opposite, which would be the height. This is our hypotenuse, which we don't really have to worry about, and this is our adjacent, which is 15 meters. The formula we used to find out the height of the rocket was tan theta equals opposite over adjacent. The angle for this example is 35 degrees. So we replace theta with 35 degrees and we replace opposite with x because that will be our height. And we replace A for adjacent with 15 meters. We then times x over 15 by 15 to cancel out. We do the same to this side so it is even. So 15 meters times tangent 35 is equal to x, or our height. That is 10.5 meters. To find out the total height, we then add 1.65 meters to 10.5 meters. So our total height is 12.15 meters.
The rocket flew lowest when we filled it with 1,000 milliliters. This was because there was too much water and that weighed the rocket down instead of making it go higher. The average height of the rocket was 5.3 meters.
The rocket flew second highest when we filled it with 800 mils with an average height of 6.5 meters.
"600 mils was the third highest. The average height of the rocket this time was 5.8 meters.
$400 mil nearly came in the last with an average height of 5.4 meters.
When we put 200 milliliters in the rocket, it flew the highest. This was because there wasn't as much water in the rocket to weigh it down. We were very surprised to see it fly so high on our first try. The average height was 26.9 meters.
We discovered that the inclinometers did not give us exact results. This might be why some measurements are not to scale.
In conclusion, the best amount of water to make a water rocket fly the highest is 200 mils.
Thank you for watching.